left off. Okay, so in 6.5, we're now going to continue with radicals. We're going to do, more operations with them, right? So the first thing we're going to learn is the product property of radicals. Basically, what the product property says is the following. If inside the radical you've got more than one element, you can separate those out and you can, give a radical to every single element in there. Now, let's take a look at this one, 4th root of 32. Now this one, if you plug in your calculator, right, I'll just show you very quickly. 4th root of 32, you're not going to get an integer. That means you have to do it yourself. So I'll just remind everybody, I know you guys know, so this is 4 times 8, 2 times 2, 2 times 4, 2 times 2. And how many are we going to group by? 4. 1, 2, 3, 4 comes out as a single 2. And then that lonely 2 stays inside. And please make sure, right, if this is a 4th root, it stays a 4th root. Now, a little bit about notation. This little index of 4, it has to be inside that little pocket, please. Okay, don't put it outside. Okay, yes.
Do you ever multiply with the, I thought when you take it out and have
If more than one thing comes out, but only one thing came out here. So there's nothing else. Okay, so now take a look at this. Okay, I have cube root of d to the 7. So basically, inside here, you know how for the 32 we broke it up and we realized that inside this radical I really had 5 2's and I grouped them by 4? If I have d to the 7, that means inside I have 7 of these d's, right? 1, 2, 3, 4, 5, 6, 7. Now, if this is a cube root, how many am I going to group them by? By 3's. So look, this is one group of 3's that comes out. This is another group of 3 d's that comes out. This one doesn't have enough partners, so he's got to stay in. Okay, so let's see who came out and who's staying. 1d came out. Another d came out. That lonely d is going to stay in the cube root. So now I have d times d, d squared, cube root of d. Okay? So look at this. 1, 2. 2 groups of d's came out, so I got d squared. 1 d stayed in, so that's my d. Okay, let's do another one. Here I have root 12. Let's do that root 12 first. So 12, 4 times 3, 2 times 2. I'm going to group by 2's. So this comes out. That lonely 3 stays in. Okay, now look. C's, I got 6 of them. I'm going to group them by 2's. 1, 2, 3. How many groups come out? How many groups are coming out? 3 groups are coming out, so C cubed. Okay? 3 bundles are coming out, so that's C cubed. Anything left to go in there? There's nothing left. So now what about the D? I have 3 D's. 1, 2, 3. I'm going to group them by 2's. This one group comes out, 1 stays in. Okay. Before I take your question, now we have an even, odd situation. Because look at the C's. I had even, and it turned out to be odd, so that gets absolute value. What about the D? Does the D get absolute value? No. Okay. Question, Sam? Huh? Why doesn't the D get an absolute value? Right, but it has to be even, odd, right? But this is odd. Yeah? Okay, Amanda. It's this little number here. So if there's nothing, it's a 2. If there's a 3, it's a 3. Okay, and then next one where I'm going to show you a shortcut. Because, okay, we can write out 6 C's or 7 D's. But what if you have like 17 D's? Okay, nobody's going to sit there and write 17 D's or whatever. So I'm going to show you a shortcut. Go.
So like for the top right, like for B, like you don't need to do the even odd situation because it's like obvious to see, right?
It's odd. Because it's odd. This is odd.
Okay. But if it was,
yeah. If this was even, then you have to do it. You have to do it every single time. I kind of mentally did it, but there was no even odd here. Okay. So now, let's do the 27. So I get 3 times 9, 3 times 3. Okay. So do you see here? This is a cube root. I'm going to group by 3s. So the 3 comes out. Okay, now look at the y. I have a 4, I have a 3. Remember yesterday we were dividing exponent divided by the index. Do you remember we were doing that yesterday? So let's do that. 4 over 3. Okay, we're going to get a remainder. It's going to be 1 remainder 1. Is that right? So this is how many comes out. This is how many stays in. So 1y comes out, and then 1y stays in. Okay, hang on. Now let's do the z. Okay, hang on. Let's do the z. Z, I have a 7 and a 3. So we do 7 divided by 3. That's 2 remainder 1. This many come out. This many stay in. So z squared comes out, 1z stays in. Okay, right? Now, questions. Ella, you had a question before?
why would we do that again?
Because remember yesterday here, I had like a 10 here and a 2, and I had to do 10 divided by 2, 5. That's how I taught you guys to do it yesterday.
I remember like understanding it yesterday.
Yeah. So that's what you understood it to be yesterday. Right? So this one, 34 divided by 2, 17. 10 divided by 2, 5. But all of these were made out so that they were going to divide evenly. Now we're going to have some that are not going to divide evenly. Okay. Yeah. You can do it in your head. I'm just writing it out so people know what to do. Yes.
Isn't that the same thing that we just did with there?
That's exactly it. But what if instead of 7 D's in here, what if you had 71? You're not going to write out 71, are you? No, that's silly. Okay?
So it's the same way to do
It's the same way exactly to do it. So look at this, for example. Look at this. I have 3 D's here. If I were to do, right? If I were to do 3 divided by 2, it would be 1 remainder 1. So 1 came out and 1 stayed in. Okay? All right, questions?
So we can do either or.
Either or. I suggest this because it's quicker, because you're not going to write out, again, if it's like a 49 and a 3, you're not going to write out 49 C's, are you? No. Although, if you forget, there is a thing that teachers say, math teachers or algebra teachers, when in doubt, write it out. That's the thing. When in doubt, write it out. When you forget, when in doubt, write it out. Group them. Of course, that's what we fall back on. But really quickly, we kind of do that. Okay. Now, that was multiplying. Okay. What if now you have a quotient? So what if you have inside the radical something divided by something else? Well, you can always split up the radical. But now we also know that it's illegal to have a radical in the denominator, correct? So we got to, rationalize the denominator. So how do we rationalize the denominator? So suppose you have 1 over root b. How am I going to make the root b go away? What am I going to multiply top and bottom by? root b, right? Multiply by root b over root b. So let's do an example. I have 5 over root x. I multiply top and bottom by root x, root x. So I get 5 root x on top. On the bottom, okay, now when I multiply these out, what happens? I'm going to get this, okay, when I multiply these out, I'm going to get the square root of x squared. Is that right? When you multiply them out? Right? So then what does that turn into? Just x. So 5 root x over x. Now, let's go to this step with the blue, right? With the blue and the black. Okay, I have root x, root x. I know mentally when I multiply these out, I'm going to have 2 underneath. That's enough for them to come out, so I could just skip to the final step. Okay? Now, what if you have a different situation? What if it's not a root, a square root? What if it's another nth root and you've got some, exponents inside? Okay? Okay. Sorry. Okay. In that case, you multiply by the same root, but inside you gotta do n minus x. Okay. Oh my God, Miss Malika, you just confused me. What am I gonna do? Okay, let's see what we're gonna do. Okay, what do we have here? We have 3 over the 5th root of something. But what is that? You have 5th root of 4. Can we simplify the 4 into the simplest bases that it's made out of? What is the 4? It's how many whats? It's 2 what? 2 2's. So it's really 2 squared, right? I haven't really done any math, have I? I just wrote 4 instead of 2 squared. I mean, that's, right? Yes? Okay, so it's like if you're 16 and I ask you how old you are, you can say 16, but you can also say I'm 4 squared, right? I mean, whatever, right? Okay, or you're 4 squared plus 1. I mean, right? Like babies, like they could, like, it's never how many years. It's always like, oh, she's like 37 months, right? And then you have to okay, remainder 1, right? Okay, so, okay, this is a 5th root. How many do we group by if it's a 5th root? 5. Now look, I don't have enough. I only have 2 in here. I need to put in a couple more, right? So what I multiply by is the 5th root, 2 to the power of, out minus in, 5 minus 2, 3. Okay, you don't have to write it in that much detail. 2 cubed. So now, how many do I have here? 3. How many do I have here? 2. That's a total of 5. Is that enough for them to come out as a single 2? It is. So this comes out as a single 2. We're going to do more in a little bit. Should I write out more steps?
Wait, sorry, can you explain again how you got from 5 minus 2 to the 2? But I understand the
Okay.
3.
So what I have now is this. 3 over 5th root of 2 squared times 5th root of 2 cubed, 5th root of 2 cubed. Everybody okay with this? I just wrote this with a 3.
But where's the 3 on top? Where's on top?
The top?
The top 3.
Okay, whatever you multiply on the bottom, you multiply the same thing on top. Huh? Okay, let's start again. Let me not write the minus 2. Okay. So times, okay, now we got to multiply by something, right? We got a 5th root. Okay, I have 2 2's in here. I need 3 additional ones. So I'm going to multiply this by 5th root of 2 cubed. Does everybody understand why I'm doing that? Yes? Yes, because I need 5 total. I have 2, I need 3 more. So now multiply the same thing to the top. So now what do I have? I have 3 times 5th root of 2 cubed. On the bottom, I have 5th root of 2 to the 5 if I combine them all. Okay? Now, this is going to be 3 times 5th root of 2 cubed. In here, I have 5 2's in a 5th root. They all come out as a 2.
Oh, so you add the purple to an exponent and the red exponent.
Right.
That's what's
Right.
And then at the end,
Right.
And then the last step is.
Okay, now I have 5. I'm going to group by 5 and I'm going to take out a single 2. Yeah. Okay, let's do a couple more and we'll figure this out. The answer is this. I know. I love them all. They're like my children. Okay, let's do this one. Guys, if you have something like this, a fraction inside, you split it up. So we split this up, root 1 over root 9. But what is this? 1 over 3, right? I'm done. Okay? Split it up. Root 1 over root 9. That's it. Same thing here. I'm going to split it up. Root 4, root x squared. Now they're each mini problems of their own. On top, what do I get? 2. On the bottom, what do I get? X. That's it. Okay, here. Cube root x to the 6. Cube root 27. Cube root x to the 6. This is like what we did yesterday. 6 divided by 3 square x squared. Is that an even odd situation? Wait, hang on. Is that an even odd situation? No. Okay. Bottom, cube root of 27. What does that give me? 3. Okay. Root 16 over root 3. That's 4 over root 3. What do I multiply by? Four root 3 over 3. Okay? Okay. Let's simplify some radical expressions. All right, so here. So usually when you have things that you're multiplying, you see how these are being multiplied, when they're separate, we like to combine them. Okay, so why don't we combine all of these? The 5 stays outside. And then I have a cube root. In the cube root, I have 100 times 10. That's 1,000. 100 times 10 is 1,000. Okay. So now I have a squared times a cubed. Okay, so now this is 5 times. I have the cube root of 1,000. Now that we can, first try on the calculator, right? So cube root, of 1,000. Oh, look, it's 10. Okay, so that's going to be 5 times 10. Now, what about the a's? I have the cube root of a cubed. It'll be just a. So in the end, 5 times 10 is 50, a. Okay, so first we combined, then we simplified. Okay.
We got the 3 exponent above the a by adding 2 and like the invisible one on top of it.
Okay, so here, 6 times 4 first is going to be 24. Now, inside the square root, we're going to simplify, we're going to combine everything. So first, 8 times 2, 16. Then, c cubed and c to the what? 4. Multiply. We're multiplying. D to the 5, D to the 3, D to the 15. Okay. 8 times 2, 16. C cubed times C, that's a total. You add the exponents, so C to the 4. D to the 5 times D cubed, you add the exponents. I'm sorry. Oh, shoot. That was D to the 8. Sorry. Sorry. Yeah, you add the exponents. Okay, so now this is 2 times. Root 16 is going to give me a 4. And then how many C's? 2. And how many D's?
6.
How many D's? 4. Okay. You have a 2 here. Oh my gosh. Okay. 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 So I get, all right, 24 times 4, 96, c squared, d to the 4. Okay. All right. The next two that I do, I'm not going to take questions while I'm solving them because I don't want to get distracted myself. Okay. Questions now.
So to get to the C to 7 being 4, can you just divide the variable?
Yes. Same thing as we've been doing yesterday. Same thing as we've been doing yesterday. It's 96. That's a 9. This is a 96, I promise. Okay. Okay. All right. So, let me finish all this and then I'll take questions. Okay. So, the difference between the two that we did and the two that we're going to do now is the radicals were being multiplied by each other. The radicals are being added or subtracted from each other. So you can't just combine when they're added or subtracted, okay? So what we're going to do is we're going to do each of them separately. 4 root 8 separately, 3 root 50 separately. So let's do this. So 4 root 8, this is 4 times. Now, the root 8, okay, I have 8, 2 times 4, 2 times 2. Okay, they come out by 2's. So one pair comes out, one stays. So I did the 4 root 8. Now, plus 3 times. Now I got to do the root 50. So let's do the root 50. 50 is 2 times 25. 25 is 5 times 5. A pair of 5 comes out, but that lonely 2 stays in. Now, I've simplified my radicals. Now I'm going to do the arithmetic. So, 4 times 2, this is 8 root 2 plus 15 root 2. Okay, now you have to see if you've got like terms. Do we have like terms? Root 2 and root 2, they're identical. These are like terms. So what I do is I combine the coefficients. 8 root 2 plus 15 root 2 is 23 root 2. 23 root 2, that is my final answer. Okay, now raise your hands for questions. So I have 3 times root 45. Okay, so let's do the 45. 45 is 5 times 9, 3 times 3. So group them by 2's. A 3 comes out, a 5 stays in. Do you see how it's literally divide and conquer. You do one bit. Now, minus 5 times root 80. Let's do 80. What times what makes 80? 8 times 10. This is 2 times 4. 2 times 2. And then this is 5 times 2. Okay, I'm grouping by 2's. So what comes out? 2 pairs of 2. A 2 comes out and another 2 comes out. And then what stays in? The 5. The 4 is split, so the 5. Okay, plus 4 times root 20. So let's do root 20. It's what times what? 5 and 4. 2 and 2. So 2 comes out. 5 stays in. Whew. Okay, so here I have what root 5? 9 root 5. Okay, minus 5 times 2 times 2, that's 20 root 5. Plus 8 root 5. So now, see if you have like terms. Okay, I got root 5, root 5, root 5. They're all like terms. So I have to combine the coefficients. 9 minus 20 plus 8. You could even do that with the calculator. All right? 9 minus 20 plus 8. Let's see. 9 minus 20 plus 8. Negative 3 root 5. Now, it could be that you end up with something like this. 3 root 5 minus 4 root 2 plus 7 root 5. In that case, you combine the like terms, right? So you would get 10 root 5 minus 4 root 2. That's very, very possible. Okay?
Would it be like 3i root 5?
No.